This presentation is on using DTrace and SystemTap with MySQL or Drizzle. So a little bit about me first. My name is Padraig. I work at Akiba Technologies in Boston. We're a small startup developing some technology related to MySQL and Drizzle. You should be hearing a little bit more about us during the week. I've been contributing to Drizzle for over a year now. I started when I was in grad school last year, and I worked for Drizzle in the summer of COVID last year. And I've hacked on a lot of random things for Drizzle. And one of those things was I took the DTrace probes in MySQL and I pushed them to Drizzle. So that was why I did this talk, to have a little bit of knowledge about how they work in both MySQL and Drizzle. So the assumption I made for this presentation is that most people don't actually get to use DTrace with MySQL in their day-to-day jobs. I mean, I'm just kind of curious how many people here actually get to use DTrace every day. Yeah, that's what I thought. So basically the whole presentation is about SystemTap, not DTrace. DTrace is awesome, I love it, but it's pointless to talk about it right now. So I have about 2 slides on DTrace and that's it. One is DTrace. Most people are familiar with DTrace. It's an observability technology developed by Sun Microsystems. There was a group of 3 guys developed it about 5 years ago. It's a pretty awesome technology. They got lots of awards for what they did. And it runs on Mac OS X as well, so you can use it on your Mac if you want to. And when the probe is not enabled, there's 0 overhead. This is if DTrace is not enabled, not present at all. There's a scripting language called D. That's what the scripting language for DTrace is, but it's not currently available on Linux. There is a port of DTrace on FreeBSD, but it's a one-person project and it's been under development for a number of years, and I don't know how stable it is. I've never used it. I don't own FreeBSD, so I can't talk about how good the port of DTrace on FreeBSD is. So that's all I'm going to talk about with DTrace really. So what's SystemTap? SystemTap is a project being developed by a number of companies, with Red Hat and Oracle being 2 of the major contributors to the project. Everything you can do with DTrace, you can essentially do with SystemTap. And that's how I'm going to show in this presentation. It's how to use it with MySQL. Like I was saying, there's a number of DTrace probes already within MySQL. So the latest version of SystemTap actually comes with a Python script called DTrace. So if you're on a Linux platform and you want to make sure you have the latest version of SystemTap, you should check that you have a script called DTrace in your path. And that's the script that's actually used to enable you to use any application that has static DTrace probes with SystemTap. And recently, Red Hat Enterprise Linux has announced that they're giving production support for SystemTap. They encourage you to try out all your scripts in development first before trying them on production. But it does have production support. That's only a recent development. So a basic overview of how SystemTap actually works. So it has a scripting language. You'll see I have lots of examples in this presentation of it, and it's very, very similar to C. So if you're comfortable with C, you should find doing the scripts in SystemTap quite naturally. So the basic steps that are performed when you have a SystemTap script and it gets run is SystemTap takes a script in a .stp file, and it actually goes ahead and translates that into C source code. C source code is then compiled by the system compiler into a kernel module. And the module is then loaded into the kernel, everything runs, and then when the script is finished running, it runs the module. So actually the first time you run a script, it can take quite a while for it to actually start. But each step, so when the module is compiled, it actually keeps it around. So next time you run the script, if you don't change it, it doesn't have to do the first 3 steps. It has to load the module. But the module will be present if you don't modify the script. And you will notice that if you're running SystemTap scripts, if you're running a fresh one, it can take some time for it to actually go through all these steps. And you can run each step individually. Here's a simple diagram of those steps in check. So you can see when you give your probe script and debugging probe, it translates it to C, then it compiles it, and it generates a kernel module, loads and executes, you get the output, and then when it's finished executing, it loads the kernel module. So that's a very simple overview of how SystemTap process works. In SystemTap, there's this terminology of probes. The idea is that there's events and handlers. Again, it would make more sense when I actually show some examples. So the idea is that when a specified event occurs, a handler is executed. And in SystemTap, they call the combination of event and handler probe. So if you hear me referring to a probe, it's a combination of event and handler. So here is probably the simplest example I could come up with. Stack, that's the command line tool that you use to interface to SystemTap. The -e parameter just says execute this as a script. And within the dash, that's my script. So you can see there's the keyword probe, and this is called .open. That's the event that I want to trace. And everything within the curly brackets, that's the handler. So together, that's a probe. So the event, whenever a system call open occurs, this handler will be executed. It will log exec name. That's the SystemTap internal function. You can call that whenever, and it will give you the name of the executable the probe is currently firing at. And file name, because it's a parameter of the system, the open system. And this is a simple output from the script, just running on my system. You can see outputs the exact executable name and the path that it's working. So that's the simplest example of the SystemTap using the one command. Yeah.
So
So the idea is that every time an open system call occurs in the system, while the script is running, it will fire. So all these different processes are calling the open system call. And that's just the output of it. And it will keep running until I press Control C. The script is continuing running. DTrace has this idea of, there's a DTrace toolkit, and there's a number of scripts in there. And one of them is I/O talk. So it shows you the processes that do the most I/O on your system. And this is a more simple version of I/O talk in SystemTap. So this is an example of a full script in SystemTap. So you can see I want to probe reads and writes to the file system there. And you see at the very top there's the global keyword. And I have 3 variables there. So in SystemTap, you don't give it the type of a variable. The type of a variable is actually inferred from the context of you use it. So, for example, the first probe that I have, the read, I'm using the read's global variable as an array. So I use exec name to index into the array, and count gives me the number of times this system call has been hit. And I do the same in write. And there's another special type of probe that you can use in SystemTap. You can see it's timer. And in this example, I have timer.s, which means seconds. But it can be any granularity that you want it to be. It can be milliseconds or microseconds. It can even be CPU quantities if you want to. SystemTap has a nice way to do for loops. So there's a for each. And the way to iterate through an array is you say for each. You give it some kind of local variable name, and it will go through your array. So you can see I'm doing 2 for each's. And printf is very, very similar to the C syntax. It's the exact same thing. You can see how similar it is to the C-like language. And the sample output from that on my laptop, when I run it, it sorts it in order of kilobytes array, and just prints out the processing in kilobytes array and kilobytes array. So we'll be more interested on a real production system. But that script is pretty simple. It's the simplest example. You can easily add more to that if you want to. And SystemTap comes with a lot of examples as well that are really, really good. So if you're interested in more system-oriented scripts like that, the SystemTap distribution comes with a lot of good examples. So one issue I have is actually getting SystemTap on your system. I would recommend going with either CentOS or Red Hat Enterprise Linux if you want to use it. What you need to do that is there's certain packages you need, and you need to have debug info for your Chrome. The SystemTap STE-debug, that's the package for the DTrace Python script comes. It's quite stable on these platforms. I haven't had any issues. It's never caused me any problems. All the examples in this presentation we run on a CentOS box. But some people, when you went to Debian, I would really recommend against using it on these platforms. You can get it working, but I've seen it's crashed MySQL for me, and getting it to actually install on your system is really difficult. Basically, you have to have these packages, the first two SystemTap packages. You have to compile the kernel with debug info. Ubuntu used to ship with debug info packages, but they're not available for all kernel versions. So you actually have to go and compile the kernel yourself. If you want to actually perform user-level probing, which is funny when we're doing this have to apply a patch to a kernel, compile that kernel, and use it. So you're actually going to need a custom kernel. I've gotten a couple of kernel panics from doing this in my Ubuntu machine. So I really wouldn't recommend using Ubuntu Debian. Go with Red Hat or Fedora. I put a small slide. Ubuntu. Yep. Yeah, if you install Fedora, Syntax, Red Hat on a virtual machine, you can use Syntax. I mean, SystemTap. Any other questions on that? I put one slide on DTrace and SystemTap comparison. I didn't really want to do much. There's lots of information on the internet comparing the two tools. I'm not going to discuss licensing issues. Both tools are now set to be safe to use in production. DTrace comes by default on Solaris, so it's always there. Not the case with SystemTap, especially on Ubuntu. I think latest versions of Red Hat are coming by default. The nice thing about DTrace is it's much more user-friendly than SystemTap. It works straight out of the box. There's lots and lots of documentation on DTrace. People who can use it to solve real problems for a long time now. So if you have problems and you want to be able to use DTrace, there's lots of examples out there. This is probably the first time I've seen any kind of examples of MySQL with SystemTap. So it's really still just beginning to do that kind of stuff. So this is the main point of the presentation. This is how you use your applications with SystemTap. So there's two ways that you can do user level coding. There's symbolic coding, in which you can use function names. If you compile the debugging code, you can actually use file names, and you can set a code level line in the file if you want to. Or the other thing is what I'm going to cover most in this presentation, is you can instrument the application with markers. It only requires us to know what the actual markers of the application are. So MySQL and Drizzle, they already come with these. They're static DTrace codes. They're referred to as markers in systems. Yeah, this is basically repeating what I said. The static DTrace codes that compatible with SystemTap. So if you want to actually go ahead and use Drizzle or MySQL with SystemTap, you have to compile it from source. And with Drizzle, those are steps. With MySQL, those are steps. Very, very similar. There's a flag to configure -- enable DTrace. If you run that, that will enable the codes, so you can use SystemTap. It works perfectly with Drizzle, but unfortunately right now, there's a bug with MySQL. I logged the bug. It's 52790. Their autocomp scripts don't correctly check for DTrace on these platforms. They're assuming that DTrace is only available on Solaris, which you can use the DTrace probes with other systems now. So I logged the bug, and I'm pretty sure they'll fix it pretty soon. So in this presentation, I actually modified MySQL myself, so I could do the presentation. I modified the autocomp file myself. And if anybody wants me to show them, I can show it afterwards. So assuming that autocomp and configure and build work fine, and we're able to build MySQL from source, you want to be able to verify that all the codes are actually present. So stat-l lists the markers that are present in the process, and you give it the path to the running process. And it supports regular expressions on markers. So here I use the asterisk to show me all the codes. And it will print out all the markers that are available in your process. So in this case, I have kind of cropped the output. But if you put a mark on any of these, so for example, delete them, put a mark there, so the code will fire will delete them. And if you don't get any output here, you're running stat-l, that means that your code is not compiled to MySQL. So that's the first thing you should do after you try and get SystemTap working with MySQL. So make sure that this output is correct. An overview of the actual codes that are present in MySQL now. There's 60 codes in MySQL scattered around 200 locations in the server. They have probes in query cache, because in Drizzle we don't have a query cache, we have probes there. There's probes in MySQL. There's probes around network and query execution. In Drizzle we started to insert probes around the optimizer, so that we can see what's going on in there. Because the optimizer is not much, you can tell what's going on in there right now. We're starting to add probes to optimizer. They're not in MySQL. So if your probes are disabled, if none of them fire, they're 0 overload. But if you have a lot of probes firing at the same time, the overload could get quite high. As you can imagine, if you have a lot of probes firing at the same time, the overload can get really high. I don't have any graphics here. I haven't measured the performance when the overload starts to be manageable. But I know last year was a DTrace talk, and they're talking about if you had like 10,000 probes per second, your transactions per second goes to about 0. So now I'm going to start to get into some examples. These are all real scripts that you can run on MySQL now if you have SystemTap enabled. And what I did was I actually created a repository on GitHub. So you can actually go and download any of these scripts if you want to afterwards or during. And you can fork the repository and add and contribute if you want to. There's a directory in there called MySQL where all these scripts are. And all the examples are with MySQL. I haven't done the Drizzle ones. I figured I'd concentrate on MySQL for this conference. And I'll do the Drizzle ones tomorrow. So this example is measuring the time spent in storage in there. You can see I have 3 global variables, which are pretty self-explanatory. The first 2 are going to hold times, and the third one is actually going to hold the query strings. So I can see which query has been what time in the storage. And the first piece of terminology I haven't seen yet is the @1. You see in my first probe I have a process brackets @1. So you can actually pass parameters to your SystemTap script. So here process @1 means I'm going to pass the name of the process that I want to monitor. So I'm going to pass the path to the MySQL D process that I want to monitor. And then I have the .mark, which is the marker that I want to have a full fire on. So I have query start, which is when query starts. And you can see the regular expressions in the second and third probes, row start and row done. Those are related to the handle there, the storage engine there. So when row start happens, that means we're just hitting the storage engine there. And when row done comes up, that means we're actually getting out of the storage engine there. And query done means the whole query is finished, basically. And in query done, I do some aggregation and printing out all the results there. The other function here I haven't mentioned yet is TID and get time of day. TID gets you the current thread ID. There's a similar one called PID, which gives you the current process ID. Because my SQL is a multi-thread server, I want to be able to get the threads. So each thread that's open, I can get the TID. The other function in here, these are all internal SystemTap functions. Get time of day, which gets you the current time in microseconds. You can change the granularity if you want to. I haven't learned exactly later. So here I'm going to get the current time of day in microseconds, and then that's how I use to calculate how many microseconds we're taking to do operation. So here's a simple output from that script. You can see the way I run it is I pass the path to the currently running MySQL D process. And I ran some simple queries while the script was probing MySQL. And it prints out the query that's being executed, prints out the total time in microseconds to execute the query, and it prints out the time spent at the engine there, that's in the storage engine. So there's something really interesting happening there. But I'll show later how you can get actually more, find out what's happening in the actual time. Any questions on that script?
The marks that are throughout the code, is there any explanation of exactly what they mean?
You mean
the different marks, like row start with,
I mean why they're in certain places?
well, is there a definition of where in the code that stuff exists? You just have to name yes from the name.
So
is there an index of the list of deep rows?
I think what they're doing is they have actually on the MySQL documentation, they have a list of all the DTrace groups. So it applies to SystemTap too. You can use them all with SystemTap. So I like to be able to know, I don't like to use microseconds. CPU cycles is very interesting to me. And this is the exact same example, except I'm using get cycles, which is a SystemTap function. And you can actually use that to figure out how many CPU cycles an operation took to occur. So this is the exact same script as before, except I changed get time of day to get cycles. I'm going to measure the same operations using CPU cycles instead. And I think it's pretty powerful. And you can see I'm running some scripts there, and the numbers being output here are actually CPU cycles to perform these operations. So we move on to another example doing query tracing. I want to find out more about what's happening in my queries. So if I want to find out how long marking is taking or how long file sort operations take, there's markers for those too. There's lots of lock start and lock done markers, so I'm just going to use the asterisks to incorporate all those markers. So I can find out what the total time for locking. There's file sort done and file sort start markers, so I can use them to figure out how much time it's taking to perform a file sort operation. So you can see I use arrays and I always index them by the thread ID. So each thread gets an individual entry in the array. And I'm using the get time within a microseconds function again. So an example, so what I did actually was I combined this script with this script so I can see more of what's happening in my total time to execute it. So you can see here, the first query, for example, the total is 287 microseconds. 6 of those microseconds were spent in network. So the more interesting one, for example, is the very last one, where I give order bytes, so I know file sorts going to be used. I can see the various things I've spent on different things that are happening in the server. I can see exactly how much time was spent doing the file sort operation. I can see exactly how much time was spent doing network file, and how much was spent in the engine. And then I get the total. It kind of helps me to see what's going on within each query, the different layers of the MySQL server. Any questions on that?
So can you just explain the network perspective? Because this is all local, right?
Yeah, so it's they have markers within the network file layer of MySQL.
So that's just more a matter of the send packet.
Probably, yeah. I mean, this was done on my local laptop, so there was no real network file going.
Sure. But okay, I guess then we probably can't calculate the entire amount because it doesn't know from the client perspective.
Oh yeah,
It's only really for send packet.
Yeah, so it wouldn't, like, if you were a client communicating with a remote server, it wouldn't include, like, the lag between client and server.
No. So you just
Yeah.
Which cities example?
They're on GitHub.com? Yeah. I'll have a link at the end. So here's another example of figuring out hot tables. So you can do hot tables reads, hot tables updates. This one is showing how many reads you're going to a certain table. It's pretty self-explanatory. The one new thing in this example is there's a probe in which fires when you finish executing the script. So no output will be generated while the script is running. All the output happens when you press Control C. So I have a simple example of running this here. And it prints out the schema name and table name and how many times it was read. And you can see the nice thing about SystemTap is it actually supports associated arrays. So you see in my probe, in the first probe there, it has user string arg1, user string arg2. So it's an associated array. And arg1 and arg2 are the actual arguments to the probe. They're documented on MySQL's website for DTrace. So arg1 to this probe is a database name, and arg2 to this probe is a table name. So I'm able to figure out what the database name and the table name are. And plus I'm incrementing a counter for this database in this table. And again, the looping in SystemTap is actually quite nice for each there. Lets you access each element of the associated array. It's pretty self-explanatory. And then with this very similar thing, except I wanted to demonstrate in this example that you can have multiple markers in the same code. So you see I have 3 markers for update, insert, and delete. So I want to be able to track all updates, inserts, and deletes that hit a certain table, that hit every table, sorry. So it's very, very similar to the last example, except I'm looking at updates, deletes, and inserts. And when I press Control C, the probe in is hit, and it will print out all the things that it's been tracking. So you can see there's a T1 table and a T2 table in the test schema, and it prints out all the updates, all the inserts, all the deletes to those tables. There's a temporary table too. You can see the crazy name of MySQL base 2 tables and how many of those operations occur to that temporary table. If I want to be able to see the queries that are accessing a particular table, I want to be able to monitor some certain table in the schema. So Similar to probe in, there's probe begin, which starts whenever you start SystemTap script. This is the first thing that gets executed by the script. And I'm passing the schema name and the table name as parameters to the script. So I'm saying I want to monitor this table and this schema. So here I just want to see what's accessing this particular table. So every time I start a query exec start marker, I get the first argument. The first argument to this probe is a query string. And user string in SystemTap is a SystemTap internal function, which converts something to a string. And it stores it in the query as a variable indexed by the query ID. And when the query finishes, I print out the query that accesses the table. So an example output from that is I want to monitor the T1 table in the test scheme. So each time there's an access to this table, I print out. More examples of the various markers in MySQL. This one is for monitoring logs. So they have various markers for the different types of logs. They have read logs and write logs. And you can actually have individual markers for those types of logs. And here I'm using CPU cycles. And you can see a very common idiom that I use, because I always have arrays and I index them by the query. I like to use that, but it's not essential. It's just the way that I do it in these scripts. So sometimes read log starts or ends. When it starts, I store the current CPU cycles, and at the end, I figure out how much log it took. Same for read logs. I use printf to print out some statistics about how long it took and what the query was. So here's an example of what the output looks like. So I say a read log started on this table in this schema, and then when that log ends, I say how many cycles it took. And I do the same for write logs. So it's kind of nice, you can see the kind of locking that's happening on tables.
With all that, go back to the screen you're on. All those examples, like you're running a script and you control C it when it's done.
Yep.
But is there any way that you can sort of like re-edit the script and have SystemTap reload? Because obviously it's obviously done on the startup of SystemTap. So
you're saying dynamically modifying what?
Well, you're running locktime.stp, and if you decided that that's running, but you wanted to change that output that you have and then put in there the timestamp, without having to obviously it's expensive to actually stop it when you start it. Is there any way that SystemTap can sort of reload those files?
I don't think so. I've never done that. Like you have to modify the script and then recompile it.
Which does the whole recompiling.
Right, because there's a kernel module loaded, right?
Yeah.
So the module is not what you want it to be. You have to be able to modify the module.
Yeah, you've got to go through that process.
So yeah, that does suck. One other thing I want to do is, Mark kind of mentioned in his keynote this morning about the performance profile, GDB. You could do something similar like that with SystemTap. So here's a simple example of getting backtraces in a user-level application. I'm using the timer, and I mean this is really simple. You could modify this to kind of shell script around it, which lets you specify how much you want to time, how often you want the timer code to fire. And okay, then target. This thing when I run a target, you give a certain process ID to the SystemTap script, and when you specify run the SystemTap script on a certain process, target represents the PID of that process. So when this probe fires, if the current PID is equal to the target, I want to generate a backtrace. So in SystemTap, there's two ways we can generate a backtrace. There's backtrace function and there's uBacktrace. uBacktrace is user level backtrace. And unfortunately, it's actually it's experimental right now in SystemTap, so it doesn't work really well at all. In fact, when I tried to run this on my particular machine, it wouldn't work. So I can't actually show you the output of this. There's a bug in SystemTap when it tries to load the kernel module with references to print, uStack, or uBacktrace, it'll error out. And there's a bug log in SystemTap. So what I was able, so instead of showing you what the output of this would be, I used backtrace, which gives you the kernel. Functions. So here I say stat-x, you pass the P process ID to the parameter, and you run the script, and it's aggregating backtraces for the MySQL process. But it's only kernel level backtraces, so I can't actually see the MySQL backtrace. But that's not a fault of the script, it's just a fault of SystemTap right now. And you can see I aggregate and I find out how many stacks are similar. So in this case, there's 7 this stack and there's 1 that stack. That was when I was doing a lot of writing to a certain table. So let's say, oh, there was 7 backtraces like this. Does that make sense? I like it because it's pretty simple to use. And it's not as big a way as using GDB to do backtraces. Like I was saying, there's a lot of examples on the SystemTap wiki, and when you get SystemTap, it comes with a bunch of examples. Early user share of SystemTap, and their system level scripts. I wrote some articles on how to actually get Ubuntu and Debian to work with SystemTap and MySQL and Drizzle. And this is the link to where all the scripts that I went over today. And I'll be putting a lot more up there too, related to Drizzle probably. So if you go to that link, you can actually go and download all the scripts. And if you want to contribute to them and modify them anyway, feel free to fork the repository. I probably won't be maintaining the MySQL ones, because I know Drizzle there. So I just mainly worked on MySQL for the conference. Any questions? I mean, do people think that they would actually use something like SystemTap?
Yes.
Yeah, I think that it still needs a lot more documentation, to be honest. Doing these things, there's no kind of documentation on any of this stuff. Sorry? Sorry. Yeah, but it's a really cool tool, and I think that has a lot of promise. Yeah. The biggest issue I had was we couldn't use it on Ubuntu.
Their debugs in those packages in the hello repository with that here. Yeah.
I'll be around anyway, so if you ever want to talk about any SystemTap scripts that are out there, I'm happy to go through any of them with you.
And is the DTrace syntax the same as the SystemTap?
It's not very similar. Like if you look at the way DTrace codes are, so if you look at a DTrace script that does the exact same thing as this, the way that they do the codes. And aggregation and things like that, the syntax is a little different.
So it's just the symbol names that are the same?
So the markers are the
Yeah,
same.
that handler read block.
In DTrace, the underscore is different, it's a dash.
You mentioned about changing the Expo file to get this to work with Script. Can you just go over that?
I can just show you how I change it.
You might want to increase your font size.
Zoom in, control plus.
So you can see in here, the way they do the auto prompt check is they check the entire operating system. And with Solaris, they say yes. So what I do is I change this from what it is, so it always. So it's not the best solution, but there's a bug log from SQL. I'm sure they'll fix it pretty soon. In Drizzle, we don't have that problem. Monty fixed it, so it actually works on all platforms.
Like, if you run this weekend on the root of run for that, and then another side of, and you have all the findings on whether
You mean the output of the scripts? I guess it would depend on your system, right? Because your scripts look for certain things. Right. I mean, the way you interpret is up to you, but the output is the same. When you code fire, the root of
suppose you have
Oh yeah, I mean, it would depend on like the machine configuration, things like that.
if they are
With a different operating system.
Yeah.
Well, you can't rely on them doing operating system scheduling. having solving problems of where the slope queries are every single day. I think what you're trying to do is maybe use some generic probes to identify higher risk things you want to find, but findings of the number, I mean, you have to compare them relative to other things. The numbers themselves wouldn't be meaningful across the recipe because there'd be a lot of other variables on the users. But, you know, particularly if you're probing inside MySQL, it's going to find
You had a very early slide about techniques on how to use SystemTap. You basically said, well, for MySQL there are markers, but the other way is using basically line source code. So that's how I would go about it. If I wanted to use this for getting information about packing, right? Instead of basically I have to go to the source and find out what
If the application doesn't have markers like this, you have to have knowledge of the source code. You have to know where you want the code to find. Which kind of sucks if you're not developing that project. You have to go through the source code and say, I want to mark the fire here. You could say a line in the source file is compiled with debugging information, which makes it a little bit easier. It's still difficult though. It's assuming you have knowledge of the application.
But if I had knowledge of the application, I wouldn't need the source to be compiled with bug.
You can,
Can I debug without that information?
yep, you could.
With any protocol?
Yep, you know.
Can you show maybe like an example of adding probe into the code, like an easy way to run with the source code? You just plot like a Drizzle code example, like that's one of the MySQL example of a probe in the source code.
Oh, in the source code?
Yeah, because that might help like in the Apache example of how simple it is to add.
Or maybe even getting a document that's right in the keyboard. People that are using it, they can add
Yeah, people should really start instrumenting their projects with the DTrace support. Definitely. It would be great to get these in more things like Apache and stuff like that. That would be great now. SystemTap exists because there was some reluctance to do that before because it's like a OS 10 and Solaris and thing. But like, why would I clutter up my code with stuff I can never use?
Yeah, so this is an example of one of the markers within the MySQL source code. So it has the syntax of all uppercase. You can actually see it's the markers are defined in a separate header file. The SystemTap will be generated in a SDT.h file. And you give it the parameters. So as an application developer, if I want to instrument my application with probes, I would say I want to have a probe like this, and I want it to have these parameters. And you insert the call to this probe when you want to in your application. In MySQL, it makes sense to insert this probe before we do parsing. So this happens before the parsing is actually occurs.
I'm sorry, I don't get the line.
Sorry. It's all uppercase. And if you want to see the actual DTrace or SystemTap probes in MySQL, there's a probes underscore MySQL.d file within the DB directory and a MySQL source code, and all the probes are in there. So they're actually really well documented, so it's actually a good way to get familiar with the probes. And you can see all the various parameters that are passed to these probes. So the uppercase macros are generated from these probe files by DTrace, or the DTrace Python script in the case of SystemTap.
And you can only use this though if you need the DTrace object, right?
These macros.
Okay. So, do you happen to know, is there a reluctance to do that? Or having that in their overhead for enabling production system
I think it would depend on how many probes are firing. I mean, if they're not firing, it's zero with it. So if you have these probes compiled into your application, you won't get any more profiling. So if you're not running any SystemTap scripts, you have these probes compiled
what I'm saying is, if you had supplied a patch to MySQL, if I'm correct, to fix their autocomp because it was only checked with DTrace on certain systems, right? So ideally, if now they can check with DTrace everywhere, then it would make sense for them to actually just enable this by default, right? Enable DTrace, right? Because it has no overhead. Non-Windows.
Yeah, but I mean, enable it by default if you find that you have DTrace as part of the building process.
No, I think what he's saying is enable it for operating systems that might enable it by default because there's no overhead.
Yeah, totally. So that's it release do that in just source code.
Yeah, so in Drizzle we can do that. We have the proper auto
You see,
context.
what I'm ultimately getting at, right, is if I have a problem with a production system, I can't take down the system, I can't recompile, right? And ideally, for a lot of people, they use stock, like if they're using RHEL or CentOS, right, they're just going to use the RPM for the doc. So, what do we have to do to get to the point
So
where
you're
the person
saying-
can just write a script and,
Well, you're saying the RPM should come with these enabled.
well, with the enable DTrace.
The possibility to use the probes.
Yes.
Yeah, I can't answer that question.
Yeah, I know you can't answer.
For
but-
DTrace, for Drizzle we can do it.
Ultimately, I think that's, the community will continue to ask for it. If the community continues to ask for it, then
Yeah.
really technical packages.
But I'll pretty much just go ahead and say that I'll get that enabled by default for Drizzle.
You should say one thing that you've already done it.
I haven't already done it.
But I mean, we can do it the next 5 minutes.
I can do it in the next 5 minutes. I'm just saying. Fine, I'll do it right now.
Any other questions?